I'm going to move on. We've got examples and understanding of benefits. I'm going to talk about runtime. What happens when you typeset a portable text document? The first thing I want to say is that when somebody sends you a PDF document, they don't send you the Acrobat Reader as well, and they don't send you the operating system that they're running on. They assume that you have an Acrobat Reader, and they assume you have an operating system. Now, unless you're in a very exceptional and unusual situation, when you typeset a text document, most of the resources in terms of size come from outside. You don't create your own fonts unless you don't think. You don't create your own text compiler unless you're Don Knuth. There's lots of things that you assume are shared, just like an operating system is assumed to be shared. And when you install TeX Live, you have the same stuff on your computer as anybody else that installed the same TeX Live, followed the same update cycle. So the document might be a 3-page, 10-page article, but its dependencies, even if they're minimized, can be quite large. Now, TeX produces identical outputs from identical inputs, and you're responsible for your inputs, but what about the other people's? And can you guarantee that the other person is using the same inputs as you are? The Git version control system solves that problem by implementing what's called a content addressable store. Normally, you store things in the file system by a path, and the way in which you make progress is you change the file at the end of the path. That's a bit like sort of an assignment statement. Whereas with Git, every data is stored depending on what its content is. Two pieces of data with different content are stored in different places. If they have the same content, they're stored in the same place. And the way this is done is what's called a secure hash, which means you compute a sort of fingerprint from the file, and it's unfeasible and impractical to forge a fingerprint. So if two files have the same fingerprint, you're either up with a very determined or very lucky, and up against a very determined or very lucky enemy, or they're the same. And cryptographic security, as much of e-commerce depends upon, relies on similar coincidences and hardness of trapdoor functions, I think they're called. So to ensure that you get the same inputs, you need to know what the secure hashes are for your inputs. And one way to do that, which is the easiest to understand, is that you record all your LaTeX inputs via storing them with a name that is the secure hash. So every piece of input is stored in the file system against that secure hash. And in your LaTeX document, you have a catalog or a dictionary. And when it says article 12.class.sty, or is it class? I can't remember. When it gives you a file name, instead of going through the kpathc stuff and saying, here's where to find it on disk, what happens is that it's translated into the secure hash that you want. And then you look it up in the file system through that secure hash. So a simple modification of LaTeX, or a simple modification of your document, and I say simple for you to do, a simple modification for your document, can put that as a prefix so that all manner of things come from a particular location that guarantees their integrity. So that's one way to do the runtime. There's another way, there's something called squashfs, which is widely used on things like routers. And that's a read-only file system that's very compact. And in particular, if you store the same file under different names, it only stores it once. And that's the same as Git. So you can have 1,000 different versions of a whole tree that differ only in particular locations. it doesn't blow up your file system because you're only storing the leaves of the tree once. And another way to do that is to write some software that allows you to mount a Git repository as a file system. And there are other methods you can do if you're willing to delve in and make the runtime of TeX do the right thing in terms of portable documents, which means get the file from the right place. So that's sort of what happens in runtime. And the main thing about what's happening there is that you have to assume that the resources you need, you've already got. And you also have to assume that there's a configuration file somewhere that translates the names to the resources. But unlike the existing system, which translates the name to a path, you want to translate the name to a content. In other words, the key thing is that you provide the secure hash of the thing you're looking for. And that's the thing that gives you the reproducibility. Because if two things have the same secure hash, they're the same. That's something we can take for granted, although it can't logically be proved any more than the sun rising tomorrow can logically be proved. That's a little bit more technical than I thought I wanted it to be. But the key idea is that when LaTeX runs, instead of looking in the file system, it looks in a special place where it's guaranteed to get things that are reproducible. And you don't have to say, oh, what version of TeX Live have you got? Are you up to, have you applied patch such and so forth, which is a nuisance in a day-to-day solution system, and it's completely impossible if you're dealing with archiving. So I'll stop at that point and ask for comments and questions and so forth.
When you keep saying when LaTeX runs, but do you mean TeX or LaTeX? Is this a part of the LaTeX macro library, or is this something that's really deep down in the depths of the interpreter, you know, like kpathc modified to accept secure hashes or whatever? I mean, you got to find these files somewhere. You got to find this content somewhere. I don't understand where these secure hashes exist. Are they in the LaTeX file or?
Okay. Yeah. So typically in LaTeX, you use an input command to bring a file in, and it's all sitting at the level of macros. The simplest implementation, everything sits at the level of macros, and you hook into the low-level command that TeX has an input command, input primitive, and LaTeX wraps that into another command, and you replace you insert a further level of wrapping, so that there's the name of the thing it wants, and you look that up in a hash table that's implemented using csname, using TeX macros. And if it finds it in the hash table, the value it gets is the secure hash it wants. And then you have to trust that the file system has got sufficient integrity that the thing that you put there or under that key is actually there. And if it doesn't find it, then your compilation fails and you're told to fetch that file, although where to get it from is a further question that I'll deal with later. Does that answer your question, Doug? At the simplest level is the level of macro, so it can be done with plain TeX. What it means is the configuration as the files you get are not done by having two trees that are almost identical, except for the changes you've implemented. You have one file for every version of every particular file you have, and you just pick and match through having a configuration file saying, this in this configuration file, go to the file that's got this secure hash rather than that secure hash. Does that answer your question, Doug?
Sort of, except that it seems like it's, TeX doesn't go out and find files. TeX goes to the kpathc library that's linked with it, and the kpathc is the one that finds files, because TeX input philosophy is all files exist in the same directory, basically. But so it seems to me that whatever the file finding backend or library that's linked in, that's the one that should be responsible for any kind of mapping between file names and secure hashes, especially since there's going to be, 160,000 times 10 of these hashes, one for every year. There's a TeX Live distribution tree, and that's going to have to be initialized into a hash table really as fast as possible. And I don't think doing it within, LaTeX or plain.tech is really, I suppose you could do it, you'll increase your format sizes hugely, I suspect. So I'm just, I'm thinking out loud here, but as someone who's implemented both a file finding library and the interpreter, that's kind of where my thoughts are going.
Okay. I'll deal with some of that anyway, which is that you can actually give a hard-coded path to TeX and configure the current TeX Live so that it goes to that hard-coded path. And in some ways, that's the safest thing to do, because then you know exactly where the file's going to come from. It's not going to come from anywhere else. And that's fine. You don't have to have in your lookup table every possible version of every possible file. In fact, the opposite. If you're running a secure document, you have to say, give me the location of every file that this document uses. And if the document only uses 50 files, you only give 50 locations. There's a sort of implicit contract that if in the lookup table a file is given, then it's needed. So if with TeX, there's a recorder command line option that lists all the files used, and typically 50 or 100 files being used. And instead of the recorder recording the path to the file, you're essentially having the recorder record the secure hash of the file. And that goes back to the content addressable store. So as long as the number of files is no more than about 1,000, with the modern TeX implementation, it will work. The font files can belong elsewhere. You might be right, and I promise to be fair-minded when I look at objections. So we have to look at some big documents and see how difficult it is and what the performance impact is on secure hashing these things. I do agree with you, Doug, that the responsibility for this sort of thing really should belong to a library such as kpathc. And that would be where we want to get to in the future. But the LaTeX macro solution that I'm providing here is something that once implemented can be used with existing TeX implementations, and that provides an easy way in and helps provide a proof of concept. So you can exude, if for ease of entry, for ease of first use, not having to have separate executables is a big benefit. You're entitled to be cynical until you see a working proof.